Hello and welcome to Bio 3468, Biodiversity and Conservation. In this first lecture, I'm going to go through the why, what, and how of conservation biology. Why we have conservation biology, what conservation biology is, and how we do conservation biology. In the lecture, we're going to take a look at why conservation of biodiversity is an issue today. We're going to take a look at about how conservation biodiversity isn't just about saving plants and animals, but also helping people out, helping humans and human society out. We're going to look at the past of conservation biology, where conservation biology came from, how it was practiced in the past, and how conservation biology is achieved today. So, first of all, why is conservation of biodiversity an issue today? And the underlying reason I got there is human population growth. There are more people on the planet today than there has ever been, and there will be more people on the planet next week than there has ever been. The increase in the number of people on the planet is increasing exponentially. To give you an idea of the short time frame that we're looking at, there were 1.2 billion people in the world in 1850. So that's when Victorian England was in full swing. The English Empire had reached pretty much its maximum extent and so on. Today, in 2018, there is approximately 7 billion people, and that is expected to increase to 9.4 billion or 10 billion people in 2050. So we've increased the number of people sevenfold from 1850 to today, and we're looking to see it increase another 25% by 2050. Now, it's true that the rate of growth of the human population in the world is slowing down as poverty is combated and alleviated around the world. The growth of the human population is decreasing. However, the sheer number of people that are reproducing today means that the number of people in total is just keep on getting bigger and bigger. And we're not looking to see the population of the world leveling off below 10 billion by 2050, even if the rate of growth of the population begins to slow down radically. So we've got a lot more people in the world today, and we aren't going to ever go back to the 1950s when there were 4 billion or something like that people in the world. We've over doubled that. So all of those people who want to go back to the 1950s, I'm afraid we can't. So this means that humans are using more and more of the Earth's resources. So for the human society, the global human society, to sustain this number of people, more resources are needed to be used. And this has direct effects on the rest of the biodiversity of the Earth, the so-called non-human organisms, which we will call biodiversity. Simply, there are three main points. There is less space available for habitats for other organisms. This is a picture of an intensive agricultural area in Australia. As you can see, 90% of the habitat has been cleared and put to intensive agriculture. These darker areas are remnants of the native ecosystems which used to exist in this area and are now almost completely eliminated except for these few fragments. So there's less space available. So all of this intensive agriculture produces food for human society. I think this in this area it's mainly wheat and maybe sheep as well. The second main point is there is more pollution from human activities. And in that pollution, we can also include global climate change because humans are polluting the atmosphere with carbon dioxide, which is causing massive temperature changes around the world. But on a smaller scale, we can also see pollution, particularly in aquatic environments, all around human cities and human settlements, which is also killing off biodiversity around the world. And the final reason why increased numbers of people means less biodiversity, over-harvesting of specific target organisms, organisms which humans find economically valuable. So in this picture here we have fish. Fish are a classic example. Many fisheries around the world have been harvested to economic extinction. In other words, the fisheries are so sparse now, the populations of the fish are so sparse that it simply isn't worthwhile taking a boat out to try and catch those fish because you simply don't get enough fish to cover the expense of running the boat. So over-harvesting of specific organisms also eliminates biodiversity around the world. And we've got plenty of examples of that from the dodo bird, which was harvested to extinction in Mauritius, and many other plants and animals around the world. Not only in modern times, but also through history and prehistory. Got some pictures here of a giant ground sloth, which existed in North America and the Caribbean, probably tens of thousands of years ago, probably around the last ice age, before the last ice age. You would have had this, what is known as megafauna, roaming around in North America and in the Caribbean. And it's thought that humans played a big role in reducing the populations of these animals so they could survive the change in environment. And humans reduced the populations of these animals through over-harvesting. This picture is representing the moa, or the giant birds in New Zealand. New Zealand, before humans arrived, had basically a avian-dominated fauna. So birds reached large sizes to fill the niches which are filled by elephants and deer and ungulates in other parts of the world. When the Maori arrived, they saw these big birds and they developed a society which subsisted on hunting and eating these birds. Before too long, many of them were, most of these species of large birds were driven to extinction, and it was only the kiwi which was left in New Zealand, which was small enough to hide from the human hunters. So massive extinctions of megafauna have occurred. And here we have ruins of a Mayan temple complex. These temple complexes would have needed extremely large areas of land under cultivation to support them. So it's thought that all through Central America and probably through the Amazon basin as well, large areas of rainforest were probably cleared for cultivation, with a subsequent reduction in biodiversity that we don't even know about. So humans, with their activities, have been reducing the biodiversity of the planet, not only in current times, but all through history. But it's at current times that we're looking at today. And in particular, the loss of biodiversity through extinction. So extinction is species no longer occurs in an area again or in the world again. The global extinction rate at the moment is about 100 to 1,000 times the background extinction rate, and that's illustrated in this graph here, looking at the background extinction rate of vertebrates and the extinction rate today, which is 100 to 1,000 times greater than what it is normally without the intervention of peoples. So the background extinction rate is the natural rate at which species will go extinct, and species do go extinct eventually. These global scale reductions in biodiversity have occurred before. These are the mass extinction events, and we'll talk more about that in the course, but never before have they been due to the actions of a single species, and in this case it's humans. The Earth will survive. I don't think the humans would be able to kill off all the species of the Earth, but because humans rely on biodiversity to support their societies, humans may not be able to survive the reduction in biodiversity. So what's that you say? Humans need biodiversity to survive? Yes, that's true. Biodiversity is needed by human societies. And we know this by archaeological evidence. And there are a few classic analyses of human civilizations in the past. One which was popularized in Jared Diamond's books, Collapse, How Societies Choose to Fail or Succeed. In the past, civilizations like the Mayan civilizations, or the civilizations on Easter Island, or the civilizations in New Zealand, basically undermined their own natural resource base. They killed off the biodiversity, and as a result, their societies could no longer sustain themselves. Easter Island is the classic example. There used to be forests, temperate rainforests on Easter Island. All of the trees were cut down, pretty much every single one of them. There are no native trees on Easter Island again today, and all of those trees were used in human civilization. Because all the trees were removed, it radically changed the ecosystems on Easter Island. So by the time Europeans arrived on Easter Island, there was only a small subsistence culture on Easter Island, which was very much reduced from the larger populations which had existed before. We can use Easter Island as an example of what is happening on Earth today, except instead of just Easter Island, we're talking about the entire world. We are undermining and reducing our biodiversity to such an extent that it could be, and while growing our populations, that we could reach a point in the near future where we simply cannot support our own populations. So how does biodiversity save human societies, or why are humans dependent on natural ecosystems? The concept of ecosystem services comes into play. Human societies rely on natural ecosystems and the biodiversity which make up those natural ecosystems in three main ways: provisioning, providing goods and services which humans need, so things like food, wood, water, and so on, and also regulating services. So these services include providing clean water, decomposing or recycling pollinization of crops, and regulation of climate controls. And finally, cultural services. Human cultural well-being is tied up in the environment which they live. So human spiritual health has been tied to biodiversity and humans having access to biodiversity. Recreation and leisure is also very important and tied up in biodiversity. So biodiversity is very important for human society. Humans are eliminating biodiversity and changing the global environment at the same time. One important point is that human society's adaptability to change in the environment is very much reliant on biodiversity. The crops we use to provide our food, they themselves need to have good diversity of genetic material to be able to adapt to those changing environments. Humans are eliminating that genetic diversity in their food crops as a part of this global biodiversity loss, and so they are making themselves more vulnerable to changing global environment. So with global warming and changes in human environments, that biodiversity is going to be needed more than ever to provide crops which don't die with these heat waves that are going to become prevalent throughout the globe in the near future. So to save biodiversity is to save the current human civilization. If we don't save biodiversity, human civilization is not going to have that adaptability to be able to survive. So that's a good enough reason to conserve biodiversity, isn't it? Do I need to go any further? So modern conservation biology is the name of the discipline which aims to conserve plants and animals that make up that global biodiversity. Preservation of the biodiversity at all levels, so that's genetic level biodiversity, species level biodiversity, and ecosystem biodiversity is considered unconditionally as an ultimate good. In other words, if the actions we must take into the future must be to preserve biodiversity or must have the preservation of biodiversity in mind. This is an ultimate good. So even if in the short term an economic gain is made from a development, if it is at the cost of reduction of biodiversity, then that goal of ultimately preserving biodiversity as an ultimate good is not preserved, and that economic development should not go ahead. Conservation biology has many different techniques. It comes from a number of different disciplines. This infographic shows natural sciences, which are the main source of science behind trying to conserve species, so biology, finding out about the species, what the species needs, its requirements, and so on. But we also need the social sciences and humanities because people are behind this crisis in biodiversity conservation. We need the social sciences and the humanities to try and tailor conservation actions so that biodiversity is conserved, and the biodiversity technique, it works, it sticks. So one lesson which has been emphasized in conservation biology is that different situations require different solutions, and a conservation biologist must be free to pull from all of these different disciplines to be able to find a solution in one particular context to save that biodiversity. So the three main goals of conservation biology according to Primac, your textbook, 2010, is to document the full range of biodiversity on Earth, because it may surprise you to know that we really do not know the full range of species and genetic variation there is on Earth. We still don't know all the species of plants and animals on Earth. Every so often we do find a new vertebrate. We find new fish all the time, and we find plants regularly. There are plants out there, species of trees, which we have not seen before. Until we know what the full range of biodiversity is, we cannot save it. We cannot put in place management systems and techniques to save that biodiversity. The second main goal is to investigate the human impact on species, genetic variation, and ecosystems to see what those impacts are, and so we can work out how to fix them. And finally, to develop practical approaches to prevent the extinction of species, maintain genetic diversity within the species, and to protect and restore biological communities and their associated ecosystem functions. So, once we know what biodiversity is, how we are impacting it, conservation biology aims to develop means to prevent the loss of that biodiversity through human actions. The Society of Conservation Biologists, yes, there is a Society of Conservation Biologists these days to share experiences and to try and learn from each other. It has 5 main principles developed to guide its members. The diversity of species and ecosystems should be preserved. The untimely extinctions of populations and species should be prevented. So we have Maurice palms in Trinidad, a population which is fairly isolated. We need to preserve that population because it may have genetic variations which are very important for the survival of Maurice palms into the future. Ecological complexity should be maintained. Evolution should continue and biodiversity has an intrinsic value. Ecological complexity usually results because of increased amounts of biodiversity. If you have large amounts of biodiversity, ecological complexity is a given, and we need to try and conserve that because that biodiversity should continue to interact with each other so that evolution can continue. We live at a point in time. Species existed before us, humans evolved, and species will exist after humans have gone extinct. Evolution changes over those species as time goes on. We should not prevent evolution from continuing. Biodiversity has an intrinsic value. So I've tried to make the point that biodiversity is important to human societies, but we should also realize that biodiversity is important in and of itself, so that we really do not have a right as humans to eliminate a species from the face of the earth. So that biodiversity has a right to exist by itself. So conservation biology is not a new science. It's not completely new, I should say. There have been human efforts towards conserving biodiversity in the past, and they have been quite successful in the past as well. So the current biodiversity crisis is not the first involving human mismanagement of natural resources. As we saw before, overhunting and overharvesting has gone on in human prehistory. Societies recovered after the crash of that biodiversity, and if the societies have had a crash and they have recovered, there are usually cultural practices in place to better manage those natural resources afterwards. So those cultural practices could be direct taboos on certain plants, animals, ecosystems. So you may have a plant which you may not harvest, or an animal that you must not hunt in a particular time of year. Okay. Um, and there may be ecosystems or places which are taboo and you cannot go there and hunt and harvest. So cultural practices could be used to put in place um, conservation biology practices which help conserve those that biodiversity, those ecosystems, and that genetic diversity. Cultural practices also could be put in place to limit human population growth. In Australia, the Australian Aborigines were thought to have gone through a population bottleneck after they first arrived on the continent of Australia, and they overhunted, overharvested, and went through a population crisis. When Europeans arrived in Australia, Aboriginal societies had some very strong cultural practices which limited the population growth of Aboriginal bands. So Aboriginal society had a stable population size, and this was developed, it was thought, in response to over-harvesting crises in the past, and enabled Aboriginal societies to maintain stability through large environmental fluctuations which the Australian environment would throw at people. So human populations may self-limit themselves, and maybe that's what we're heading for in the future today. These cultural systems, or often codified in religious systems, have largely been swept aside by expansionist systems of agriculture. So this is driven by capitalism and European economic theory, which emphasize growth and the capture of more and more resources. In Europe, the development of technology and agricultural technology enabled more and more land to be captured and brought into agriculture. So as a result, in Europe today, 95 to 98% of the land surface in Europe is human altered and human managed. So this, for instance, is a example of I think this is actually Texas in North America. Again, a landscape which has been extensively modified. Conservation biology is struggling to be taken seriously in this socio-political environment where the emphasis is on economic growth, it's on making money, it's on allowing people to use natural resources in such a way for short-term environmental goals. So most of this course covered techniques conservation biology has developed to prevent biodiversity loss in this modern capitalist context. Because even though the European model of agriculture was developed in Europe, it has been exported around the world. So most European landscapes today are human modified. So if you go to the UK or England, you'll hardly see any natural ecosystems. Every ecosystem is managed in some way. Even the so-called biodiversity rich ecosystems in England are in reality a human modified and human managed ecosystem. So for instance, the chalk grasslands or the moors in central England are all human modified landscapes. And European colonialism exported these systems and attitudes to biodiversity throughout the world. So many of those cultural and religious biodiversity concepts, conservation concepts, were eliminated by this Western agricultural thought. And so that is probably the origin of the problems that we have today. There were some positives, however, from this European expansion of agriculture. Knowledge of biodiversity and naming of organisms really owes its existence now to this European expansionism. If we haven't had those Europeans going to all parts of the world, collecting all the organisms and bringing them back into museums in in Europe and in North America, we wouldn't really have an idea of the numbers of organisms which exist in the world today, and we wouldn't have a naming system which allows us to cope with all these different species. Some management of landscapes wasn't completely disastrous. There were some practices put in place, such as protecting slopes and uplands throughout the British Empire, which did enable some preservation of biodiversity and the ecosystem services which goes with it, and also reservations of forest for timber harvesting. One of the European values of forests was for harvesting for timber, and in particular tall trees for building ships. So Europeans thought that having forests around was a good thing, so they reserved forests. They prevented clearing of these forests for agriculture. So in effect, they brought into effect conservation biodiversity practices there. So in North America, which is effectively an export of the European agricultural systems, some developments occurred which allowed modern day conservation biology to develop. North American conservation biology reflects that development of a will to conserve biodiversity in that capitalist, that European agricultural environment. Similar developments have occurred in Europe and in other developed countries around the world, but your textbook is an American textbook, and it does tend to concentrate on that North American development of conservation biology. Two main approaches seem to have been followed. The first one is a preservation approach, and that valued biodiversity for its own sake. It followed what is known as an intrinsic view of the worth or the value of biodiversity. And this worked quite well in North America because there were still large areas of land available and not cleared for agriculture. And the protagonists of this approach, the preservationist approach, worked to establish national parks, which were preserved parts of biodiversity in North America. It was still only a small amount, but at least it was something, and we didn't end up with Europe where nothing was conserved. Resource conservation approaches were a more steady state approach. This developed from natural resource management. So in the same way that in the British Empire, uplands and mountains were preserved because it was thought they preserved the rains and preserved rivers and streams. In the same way, natural resource management, which aimed to provide trees and timber, were developed and began to include all biodiversity in natural resource management, as some practitioners of natural resource management saw that if you didn't preserve all the biodiversity in a forest, then that forest would generally decay over time. So the natural resource management ethic came to include all biodiversity. So these two approaches converged on conservation of biodiversity from two very different directions. And both of these approaches are used today, not only in North America, but also in other developed countries and developing countries around the world. The resource conservation approach seems to be better in developing countries where poverty is still a big issue. So people do not accept that biodiversity has a right to exist in the face of human suffering. So if human suffering can be alleviated by elimination of biodiversity, many developing countries will take that route. It's simply because humans are prioritized above all other biodiversity. There has been recently, within the last 10 years, a recognition of ecosystem services that we will talk about in the next lecture, where natural ecosystems and biodiversity provide human goods and services for humans, and human society cannot survive without those ecosystem services. So that is being used as an argument to preserve biodiversity in these developing countries. There's still much debate about this because economic growth usually gives or usually is still at the expense of biodiversity. And developing countries where the majority of biodiversity around the world still exists demand an economic development to eliminate poverty. And you can't really gainsay that. The Europeans sacrifice their biodiversity for economic development. So developing countries want that same opportunity. So ultimately, conservation biology is about developing the preservation of biodiversity with economic development. Biodiversity has to make do with less room and less resources as humans take more of it. So conservation biology aims to structure that remaining room and those remaining resources to maximize the biodiversity that can be preserved in a human modified world. So hopefully that has given you at least an overview of what biodiversity, conservation of biodiversity and conservation biology is all about. So read chapter 1 in Primac and will give you a more fuller view of what's going on. Okay, that's the end of the first lecture. Thank you very much.